Hey everyone, Roland this side. I hope you all are doing well. So let's say the problem of the day.
So the problem here is 3020. We have to find the maximum number of element in subset such that it makes a chain. Okay, so we have to find number of elements in a chain. And what is a chain here? So chain basically starts from, like, for example, we have starting from 2. So it goes over twice, I mean power of 2, power of 4, starting from power of 1 to 2 to 4, then power of, I mean 8 until a peak, suppose power of k, 2 to the power k, and then again go to 2 to the power of k minus 1, k by 2, 2 to the power of k by 2, 2 to the power of k by 4, till 2 to the power 2 and 2 to the power 1. Okay, here 2 can be anything. Okay, 2, suppose we have x as 2 and it goes in a increasing and decreasing order. Okay, we have to find the longest chain, such that if we look here, the longest chain we have is 1 to the power 1, 1 to the power 2, and 1 to the power 1. Okay, so first chain is this, and the second one is 2, 4, 16. Okay, so we got 2 to the power 1, 2 to the power 2, and 2 to the power 4, 2 to the power 2, and 2 to the power 1. Okay, so this is 2, 4, 16, 4, and 2. Okay, so this is the second longest chain. We got 2, 2, 4, 4, 16. And we see the third longest chain in this array, that's gonna become 3. Okay, not starting with 3. Let's start with 9. 9 to the power 1, 9 to the power 2, 9 to the power 3, 9 to the power 2, and 9 to the power 1. Okay, so another longest chain is this, where it goes like something like 9, 9, 81, 81, and 65. This represents 9, this represents 81, this represents 6, 5, 6, 1. Okay, like that. So how we are going to calculate this is some, like, we are going to use, I mean, so I mean, it can be in any unarranged order. Okay, so basically we can, if you want, we can sort and arrange, but beside of doing it, we have to first, basically we have to count these things. Okay, so basically we first of all, let's store this in some kind of, I mean, data structure. For to count the frequency, the best we are going to use it, uh, unordered map. Okay, so let's first store that and see what we can do next. Okay, so for example, what we are going to do is, for int element on nums, we are going to store that on an unordered map called, let's call it let's call it frequency. We are going to store the frequency of every element. Okay, after that, what we are going to do is, we have to, I mean, get this. Okay, so instead of, if we can see this in another POV, it look like something. We got x to the power 1, x to the power 2, x to the power 3. If we got 3, its frequency is 2, its frequency should be 2, its frequency should be 1. Okay, it can be greater than equal to 1. Okay, its frequency should be greater than equal to 1, and it's also greater than equal to 2. They are all frequency. Okay, we have to, for the chain, the end element's frequency can be, so the frequency of and element should be greater than equal to 1, and rest all gonna, frequency of rest all elements should be equal to, I mean, frequency of rest of all elements should be greater than equal to 2. Okay, so we have to count that. Okay, and calculate the length while counting. So what we are going to use is, now let's iterate over our frequency array. Okay, so we can do something like auto, so called it base, and the frequency, called it count the frequency in our frequency array. I mean frequency map. Okay, it's not array. So first of all, if base equal to 1, we can continue. because in case of one we can have something like 1 1 1 1 1, and that's not, I mean, that's not follow, because powering up one doesn't sum up its remain one, so we are going to handle it later. Okay, so for now just skip one, I'm going to handle it later. So if base equal to one, we're gonna, I mean, just pass it, and now stored it in. Now let's it typecast our base into long, so it doesn't exceed limits. Okay, so what will gonna be, it gonna, let's call it chain. Okay, so the first element of chain. So to continue this chain, the first criteria is to, okay, so we have to calculate the length of the chain. So length equal to 0, it can be integer or any type. So we have to calculate the chain, so we have to keep iterating over another while loop till we got the end of chain. Okay, so first of all, to calculate the chain, the frequency should exist. Okay, hold on, wait, frequency of chain should exist. Okay, so it should greater than 0 to continue. And after that, what we are going to do is, first of all, if, I mean, frequency of frequency of chain is greater than equal to 2, and frequency of chain times chain is greater than equal to 1, what we can do is chain equal to chain times chain, and this we gonna increase length by 2. Okay, so what I have written here is, for example, we have something like x, so what, in the next element that's gonna become x times x, that's, I mean, the next element gonna become x times x times x. Okay, it's a 4 times, and similarly it again gonna become double x and then again x. Okay, like that. So if we got, I mean, for example, here frequency of x is 2, frequency of double x is, I mean, for example, 2, frequency of 4x is, let's consider it also 2. Okay, for example, for this case we are considering it. Okay, so for example, our, I mean, the current chain started from x. Okay, so is frequency of x exists? Yes. Okay, so we have to now calculate the length. Okay, so frequency of chain is it greater than 2? Okay, so we can count x in chain. So let's form the chain. Okay, so the first element in chain is equal to x, and first of all, if we are increasing length here, okay, by 2, so the this x can only participate in chain. Okay, if we can only increase its length of chain by 2 if we are sure. Okay, I mean, let me write it when we are going to increase it by 1. Okay, when we are going to increase it by 2. Okay, we are, when we are sure that the mid element exists. Okay, we are checking the first and last, I mean, the left and right element exists from this center. Okay, there can be another, so we are checking the left and right exists, so it's greater than 2. Another thing to check is, I mean, if it's exist or not. Okay, the center element. Okay, for example, if it doesn't exist, okay, the frequency of double x is 0, and we do length equal to plus 2. Okay, so we got length equal to 2, but if you carefully see, the chain here formed is actually x, and 4x is another chain, and this is another chain, and length of this chain equal to 1, and the length of this chain also equal to 1. Okay, so we miscalculated, so we have to check is the center element exists or not. Okay, we got x, so we have to check there might exist a center element double x, then we can increase the length by 2. Okay, and we are going to add the length, make it 3 by adding it in our else statement. Okay, so how we are going to add this is something like, hold on, let me change the color. So else, if it's, okay, else what we are going to do is simply increase the length by 1, and now break the loop. Okay, so what it basically does is if it's not greater than equal to 1, okay, for example here we got x, for example here double x equal to 0, okay, and we got x in our frequency of x is greater than 1. So if we check is frequency of x is greater than 2, yes, so we got two x's from left and right. Now we have to check does we have the center elements. Okay, so here it's not, we doesn't have the center element, we doesn't have the, I mean, frequency of double x is not greater than equal to 1, it's 0. Okay, so we simply increase length by 1 and break out the while loop. Okay, so length we got is 1, that is this one. Okay, and what if, let's consider what if frequency is actually 2. Okay, so now, I mean, first x, I mean, chain started from here, so x is greater than 2, frequency of chain that is double x, which is greater than equal to 1, so length gonna become, we are going to add 2 on length. Okay, and length is initially 0, and now chain become change times change, so that is 2x. Now again we check is change times change that is greater than 0. Okay, I mean double x is greater than 2, yes, it greater than equal to 2, yes, it's 2, and the chain times change that is 4x, which is greater than equal to 1, yeah, it's actually 2. So again we do double 2 on length, and now chain becomes 4x. Okay, so now check 4x, is it greater than equal to 2, yes, it's actually 2, and is 8x is greater than 1, we doesn't have 8x here. Okay, I mean x to the power 8, actually we didn't have x to the power 8. Okay, so we, I mean, run the else statement, then do length plus 1, and we break out this while loop. So actually we got length equal to 5, and if we see length actually here is 5. Okay, we got 2x in left right, we got 2x square in left right, and we got x to the power 4 in center. Okay, so the length actually is 5. Okay, so that's how we calculated the length. Okay, so I think at last we can do is we have to calculate the maximum. So we can do is maximum of answer and length inside our while, outside our while loop. Okay, so here it ends our while loop. Basically, if we do it, let it color blue. Okay, so inside our while loop we got this. Okay, for about 1 we can handle it once simply like this. If, I mean, for example, so now for ones we can simply do number of ones equal to, let's count number of ones. So if we got number of ones that is greater than, I mean, if we got number of ones, so if we have ones in our, I mean, map, or call it frequency, we call it frequency here. If we have one in our frequency, we are going to do the number of ones gonna become frequency of 1, or else it gonna become 0, and answer equal to maximum of actual answer, comma. Okay, so one chain, let me take it a bit down. So one chain, what is the length of chain of ones we got? Okay, so the chain gonna become ones modulo 2 equal to 0. If it's true, I mean, if it's true, okay, equal to 0, then it means the length is even. So we are going to do is ones minus one, length is even means we got 1 2 3 4 1. Okay, so but the length gonna become like 1 power 1 and this power 2. Okay, so we can consider this as chain. So we cannot, at any case, we cannot get any odd chain, I mean even chain. Okay, there must be a peak and there must be equal element in left and right in monotonic form. Okay, so at any case we are not going to get an even number of length. Okay, so if it's even, we are going to subtract it by 1, or else keep it 1. Okay, or else keep it 1, and maximum of one chain we can do is here, my handwriting, maximum of one chain. Okay, and I think that's it. We are simply going to return the answer like that. And now if we have to code it now, okay, so let's code it and see if it's working or not. So now let's consider an unordered map, unordered map of long type. and that one I store the frequency and x in nums. We are going to increase count the frequency of every element in nums, and after that what we are going to do is for auto and base and count. So it's base count in our frequency. So if base is 1, we're simply going to continue, and now let's typecast for to avoid overflow. So call it chain, gonna become first element of base and length starting from 0. So while it's not, we have the what we call we have the chain in our map, we have chain in our frequency. What we are going to do is we have chain in our frequency and chain, and after that what we are going to simply if frequency of chain frequency of chain is greater than equal to 2 and frequency of a chain square is greater than equal to 1, where let's increase length by 2 and do the square of chain times CHAIN, and if it's not the left and right, it must gonna be the peak. So for peak we are simply going to do length plus plus and break out. Okay, and after that we are going to calculate the maximum for every length. So result equal to maximum of result and current length. So we have to get the end result equal to 0, and for ones what we are going to do is we have to handle ones. So we are going to do and number of ones equal to count if we have count in our frequency. Okay, if we have count in our frequency, we are simply going to get the frequency of 1, else it's gonna become 0, and length of ones. So that's gonna become if ones modulo 2 equal to 0. That means if ones is even, we are going to do subtract 1 once by 1 and decrease 1, and else simply gonna return 1. Okay, and one more time let's calculate if we got max as 1, max equal to result comma current length. Okay, and at last return our result, and if we run the code, I think we can have a better form to check it. We can again use our count. Let's see. Okay, so now let's submit the code and see if it's working now or not. Oh. Okay, so it's worked perfectly fine, I think so. And now if we see space complexity and time complexity of our code, so time complexity gonna become time complexity simply gonna become big of big of and for the outer while loop and for inner for outer for loop, and for this also it's gonna become big of, and for this also big of big of and for this at worst, if we got a very long chain like 2 2 4 4 16 16, at worst it can gonna go big off, and but it only going to get it once. Okay, and after creating this chain it never gonna visit that. Okay, so at worst it's gonna big off, and if we see, I mean, possibly we can go to big off. And okay, and in space complexity, we are using an unordered map. So at worst, if we got all element were different, at worst it can go to big of. And so that's the space complexity and time complexity of our code. And I hope you like this video. So please make sure to subscribe to Tenzor and feel free to ask any doubts if you have in comments. Until then, keep smiling and keep coding.